I'm a host. I think I can get the slides up now. We are recording films. Oh. Oh, the slides are if you click on the lecture title now. All right. We are recording Casey. Yeah. Yeah. Oh, I just added the slides. Sorry. Yeah. Just put them up. Just pushed. Yeah. I tested it locally. Okay, yeah, sounds good. Go for it. It's like we're doing okay though, so far. Hi, everyone. All right. If everyone can raise their hand if they have a seat next to them that's empty. All right. I will note that the fire marshal is being very strict with us this time. They said that they will charge us about $100,000 if we violate the code. So for those of you sitting in the alleyways, that is not allowed by the fire safety code. If you want to pay $100,000 for the fine, you may stay there. But otherwise, please go to seats. All right, and keep your hands raised if you have an empty seat next to you. Karaoke. Oh, right, pop sounds. You want to go? Wait, I have mine? I haven't picked my time yet. I guess I'll tell them later. I have tentative times. I'll just put yours up, and I can just say mine are coming soon. I'm still waiting to find out when a certain key meeting is. All right, there's still a few seats up front. You can come down here. 1, 2, 3, 4. Yeah. Good, good. Yeah, so we still have a few seats over on this side. If anyone else can come. This rules. I can't believe we got the numbers exactly right. Let's see how many people we have
Show up at 111 or whatever.
at eight to nine.
Yeah. Might just be you and me.
Let's give them it's 110 soon. How much time do you need for your
Oh, my part?
Yeah.
We could do, I could be adaptive.
All right. I'll aim for 20, 25 minutes.
Yeah, that's good. 20, say 22. And if you go over a little, it's okay.
Okay. And then let's see here. Are we on Zoom already? Did you turn on Zoom?
It's on Zoom, yeah. Although, is everything set up totally? I'm logged in. Oh, no one's there though. Oh yeah. Huh. Oh, there, we gotta let them in. Oh no, attendees. Okay, we're good.
All right.
Yeah, turn it.
Hang on. Let me check chat.
Yeah.
Is everything connected properly?
What's this resolution? No, you're fuzzy. One sec.
All right.
Yeah.
Let's also do share screen.
You can share my whole screen. That's fine.
Yeah, that's probably best.
Yeah. I closed everything. See. All right. The secret documents.
And let me just All right. How's everyone doing? Welcome to CS61B. All right. Zoom, can y'all see us? Let me just make sure that.
There's a spot over here if you're not.
All right. Zoom chat, can you hear us? All right. Excellent. And chat is on now. All right. Welcome to CS61B. Let me just hide video panel, hide floating meeting controls. It's going to be recorded. All right. Welcome. So before we get started, we kind of like to do a brief overview of how this class is going to work. All right. So what is 61B? Now, if you've heard anything about this class, you've probably heard that this is a class where we teach you Java. That's honestly not really going to be the focus of this course, right? We are going to be teaching you a new programming language over the first few weeks called Java. But really, we're doing that mostly as a way to introduce a few new concepts to you. In 61A, kind of your goal was just to learn how do you program, right? You were given some assignments, you were asked to write a program about it, and then you submit it to an autograder and you got results out. This class is more about how you code efficiently. So this has a few flavors to it. For one, we want to write code that runs efficiently, right? If you remember back in 61A, we started off with a recursive Fibonacci function that took an exponential amount of time that really couldn't solve any Fibonacci number greater than, let's say, the first 40. We're going to be looking more towards those algorithms that can solve, let's say, Fibonacci up to the nearest 100,000 position or the millionth position even. So that's going to be using good algorithms. We're going to be discussing certain algorithms, for example, for sorting. We'll be discussing data structures, which are these kind of tools that happen to be very useful in a lot of different problems. In addition to writing code that runs quickly, we also want to discuss how do you write code very quickly yourself, right? You don't want to be spending hours upon hours trying to solve this very small piece of code. You want to know how do you write code within only an hour or so and get some meaningful results out. So this will be like designing, building large programs, working not just by yourself, but working with partners. We'll be discussing a lot of programming tools that end up getting used in real life. Git, IntelliJ, JUnit, All of those things are used in modern industrial settings, although we will be simplifying a few things for the purpose of this course. Now, if you're here in this course, we are going to assume some solid level foundation in a programming course. So if you've taken 61A, that will qualify. These are things like object-oriented programming, recursion, lists, trees. We will have a few early assignments that are designed to kind of remind you about anything that you may have lost from 61A, just to get everyone up to speed. Now, other than that, some of the great features about 61B that we'll be covering a lot of these cool data structures. And as it turns out, a lot of software interviews tend to talk about these objects. So we kind of say that 61B is kind of the most important class you'll take in Berkeley if you're just going for a software engineering interview. Other than that, we'll be covering a lot of really cool math, asymptotic analysis, array resizing. 2-3 trees and red-black trees are these special kinds of trees that are designed to stay balanced. We'll be discussing that. And then towards the end, we'll be discussing things like graph theory and the P versus NP problem, which if you can solve, you'll earn $1 million. Yay. Perhaps most important though, by the time you leave this course, I want every student to be able to build whatever program they want. 61A, you're basically taught just how do you solve this problem that we gave you. By the end of this course, we want you to be the type of person who can get a problem in real life, like maybe your laundry schedule isn't working properly, and say, I can write a program for that, and then spend 3 more hours than necessary to actually solve the problem. All right. So we'd like to introduce ourselves as the instructors for this course. Josh.
Hi, everybody. Okay, so I'm Josh Hug. I do a lot of the videos I recorded back in the day are available, so you may see me also on those. But yeah, so I've been around Berkeley since 2014. I was an EE undergrad at UT Austin. I didn't take my first CS class till I was in grad school here. I taught at Princeton for a few years. That's where I learned to teach data structures. I was on sabbatical last year in the Netherlands. Anybody here Dutch? Speak Dutch? Yeah, there we go. Good, glad to hear it. Anyway, I'm going to plug just briefly. If you don't like coming to lecture, the elementary Dutch class taught by Esme is quite good. It overlaps this class, but if you just watch the videos anyway, I sat in on this class last semester. It was great. So just a plug. If you want a foreign language, Dutch is great. Dutch is like a very good language. It's the easiest language to learn, in my opinion, if you're an English language speaker. And I watch trashy Dutch TV now with Dutch subtitles. We've been watching Vias de Mol, of course. But we've also watched Good Luck Guys and F-Boy Island, Netherlands edition. Anyway, this is my 11th time teaching 61B, but it's been 2 years since my last time. I did a lot of the course design, including most of the homeworks and projects. I'm going to be teaching a lot of the beginning of the class, and then Justin and I are going to switch back and forth. Anyway, that's all from me for a little bit. I'll come back in 20 minutes.
All right. So hi, I'm Justin. I've been a lecturer here since 2022. I got a BA, BS as a double major here in math and computer science. If you're going down that path, I will say that taking math and CS is a great synergy of majors. After that, I went back here, did a 5th-year master's, and then kind of immediately went into lecturing here. This will be my 5th time teaching 61B. I did just come back from MIT Mystery Hunt. Did anyone else do that, any chance? No? I have figured out my office hours. So they are going to be Tuesday, Thursday from noon to 1:30. I forgot to add in Soda 329. So I'll add that to the slides later. Josh, your office hours are still TBD. All right. Nice to see everyone. Hello. Nice to see everyone. All right. So before I get started, I'd like to just kind of do a quick survey of the class. So what does everyone hope to gain from this class? Why are you taking this class? How do I get out of this? Okay, there. Anyone want to volunteer? Reason? Internships. Anything else? Huh?
Be required. Required for degree, I guess. Do you mean like it's required that you get a degree? No, other way around. Got it. Required
Yeah, the class is required for the degree. That is a very compelling reason to take this class. Yeah. How to build projects, that's a great reason. We want. Yeah. Anything else? Yeah. Yeah, getting better at object-oriented programming, that's definitely a good reason.
I'll do the transcript.
Yeah, that's probably that.
Yeah.
Anyone on Zoom? Knowledge deficit spelling. That's probably not right.
It's official. All right.
All right, anything else? Yeah. The sticker. Yeah. All right. And since we will be doing a lot of group projects, I will ask that you kind of introduce yourself to the class, kind of as a whole. So just how many people do we have that are freshmen in this class?
Ooh.
All right, any sophomores in the mix? Juniors? Seniors? Any grad students?
Fun.
Any other grade that I'm missing? Concurrent enrollment? Yeah. All right. How about major? How many people here are CS majors? All right. Data science? Anything else? All right. Intending to declare CS data science? Yeah.
Oh, interesting.
Math? Econ? Anything I didn't cover?
Yeah.
Yeah.
Eeks. Oh yeah.
Okay.
Oh yeah. Well, okay. Let's do Eeks separate hand.
I may have just made a controversial mistake.
Wow.
Eeks is a subset of, or no, CS is a subset of.
Oh, right.
Okay, I should stop. All right. Any other majors that I missed?
Stats.
Stats? Yes, that's a good one.
Physics.
Yes. All right. And how about experience? Have you taken 61A? I think CS 88 is an alternative nowadays.
Yeah.
Any other programming classes?
E7.
All right. How many people have experience in Java before?
No Java also.
Experience in Python?
Most
people.
Okay, how about no Java?
No Java experience?
Come on, no Java. Hands up. There we go. Okay.
Yeah, no worries.
It's supposed to be about half and half. That's usually what happens, but maybe it's not half and half.
All right. Any other languages? C++? C? JavaScript? All right. MATLAB? All right. All right. So there's a wide diversity of students here. I will definitely recommend that you talk with people after this class ends. Get to know people. You will be using partners for some parts of this course. Definitely get to know friends.
All right.
All right. Now let's go into some quick logistics, shall we? All right. So if you're still trying to join the class, we do not have direct control about getting into the course. Please contact a major advisor if you have any questions. We do add people to course platforms, but it is a manual thing. So we only do this every day or so. Don't email us just to be added to the platforms. Don't email our personal emails. At the very least, if you go to my email, it is going to get lost in about 30,000 unread emails. So please email the cs61b@berkeley.edu email. Do not email us personally. And don't email us unless it's been more than 2 days since you joined the course. We are going to try to add people every day, but it is going to take time. If you're a pending concurrent enrollment student, I think we haven't approved in a while, but we're probably going to approve most students who are requesting it. you should be added a few days after you submit your application. There is a bit of a delay because there's some like back-end logistics stuff that needs to happen. Don't email the course staff until it's been more than 2 or 3 days. All right. So this class will have lectures every Monday, Wednesday, Friday here in VLSP. We'll also have them screened online via Zoom. And these are going to be kind of to form this kind of introduction class. In practice, you won't be learning too much from the lectures because you'll be learning a lot more through doing itself. So the projects, labs, homeworks, those are where you're going to get the most learning out of it because that's where you're actively trying to solve things on your own. And we will be presenting a list of problems throughout the course via our homeworks and projects that we consider interesting and useful to train you on this journey. Now, we'll roughly split the course into 3 phases. This first phase is going to be very fast. It's kind of getting you up to speed with all the tools we'll be using in this class. So that's Java, that's Git, that's IntelliJ. It's all going to be solo work because we want everyone to have that good foundation. And it is very fast. We have a homework due on Friday. Around that time, at the end of this, we'll have our first midterm. And then phase 2 will start, where we start discussing the data structures, kind of the core of our class. Coding work is still solo at this point, but we'll be discussing kind of like things fast-paced. If you miss out on a week of material, don't worry, we'll probably do a reset and discuss an entirely different data structure within the next week. It'll be moving moderately fast. After that, around phase 3, that's around weeks 12 to 14, just shortly after spring break. That's when we go into our algorithm section. At this point, we actually slow down on the course a lot because by that point, you're not learning as much from lectures, you're learning more from doing yourself. So we'll be giving a lot more time for this final project where you'll basically be building an entire project by yourself with no starter code. So that will be done in pairs. It is going to be slower in the class because of that. And we'll be having a lot more time for you to work just on that. In terms of your course grade, you will be getting 4 types of points. Weekly surveys, course evaluations, those are going to be kind of these low effort things. You should be getting most of the points for those. Homeworks, projects, and labs, those are going to be the high effort things. You will be spending most of your course time working on them. We do expect about 100% scores on those if you put in the necessary work into them. Exams are going to be high effort as well, but they're not going to be perfect scores. We do target around a 65% average. We do have a clobber policy where if the final exam score is better, then we'll take that score to clobber your midterm scores. And we do also have a policy that if the average grade is too low, less than 65%, then we'll reduce the maximum score so that it is a 65% average because we kind of assume that the exam was too hard. We do have some pacing points for attending discussion, lab, lecture, that kind of thing. It's a small amount of extra credit, so you won't be penalized for not attending anything. But if you do attend these things, you will be getting some extra credit. That only counts up to a B-. Kind of the intent is we don't want to penalize students who don't learn effectively through lecture, lab, or discussion. Not everyone is going to learn the same way. But if you are claiming that you learn best by not attending lectures, then you kind of have to prove it to us by scoring a high enough grade without those things. So B- or higher, you will not be affected by attending lectures or anything. If you're below B-, then you will get a small amount of extra credit just for showing up to various things. And we've set the B to B+ threshold to be a 65% on exams, so about median, and a 95% on everything else. So you do have a bit of a buffer there if you want to go for a B+. Full details are available on our course website. We have an entire course policies page available for you. Any questions before we move on? All right. Now, I kind of hate to do this, but I have to do this every semester. Please don't cheat. Last year, we had about 100 cheating cases, mostly from project copying. I think a lot of them were because ChatGPT likes to copy solutions from this particular repo that we happen to know about. So do not use ChatGPT for this class. It is not going to end well. Now, I kind of like to go over like some more like reasons why we feel that students cheat, kind of to explain why we feel you shouldn't be cheating. Like, I'm going to say that anyway, but at the very least, I should be giving you reasons for this. So I think that a lot of cheating falls into one of these three categories, right? You have this case of accidental cheating, where you kind of don't fully follow the rules of the class, but that's just by accident. You have cases where you believe that rationally you'll earn a better score through cheating, which is thankfully very rare. And then you have this case where you are struggling at a deadline. You have like 3 other projects due the same day. And in a moment of weakness, you just end up having to cheat. That also ends up being fairly common. And I'll kind of try to explain why in these cases you shouldn't be cheating. So first off, if you accidentally cheat, you really should know the course policies. Generally speaking, our philosophy is that we want to maximize the amount of learning that gets done in this class. So if something that you do can potentially let someone get a non-zero score on something without learning material, that would be what we consider over collaboration. So as a reminder, we are not a Java course. While we teach Java, that's just a tool to let us learn our data structures and algorithm design stuff. So it isn't it is considered cheating if you just tell a friend, like, oh, in order to solve this problem, you just do this particular thing, and I'll let you write the Java on your own so you get the experience. That's not how this course works. So, for example, things that aren't allowed, you can't use a friend's solution as a reference. No matter what, if you have in possession someone else's code or code you found online, that is considered misconduct. We will penalize you for it. If you use LLMs like ChatGPT or GitHub Copilot to come up with an algorithm for you, that is also considered too much work. Even if you don't do that, if you're just like looking for syntactic stuff, that is considered kind of a gray zone. Make sure you cite your source if you ever use code like that. If you work with a non-project partner in a way that you both end up with the same underlying solution, that is also considered to be academic misconduct. So we do allow for some high-level discussion, kind of like breaking the main problem down into about 2 or 3 subproblems. That will be around where we consider the limit. Rubber duck programming is a really good tool. If you don't know what that is, kind of you just talk to a rubber duck, explain your problem, and you magically learn how to solve the problem because you're trying to explain it to someone else. It ends up working surprisingly well. And if all you really need is the Java syntax, then we do kind of give an exception for that, but be very, very wary about that. Be careful. Now, if you're thinking that maybe you're going to get some advantage out of cheating in some of the assignments, many of our policies are specifically designed to deter that. So first off, if you get caught cheating on an assignment, that's an automatic 0. We're going to give you a 0 on the assignment. If you believe that you can do better on an assignment by not cheating, you probably should be doing that. We will also refer you to the Center for Student Conduct, which can lead to multiple penalties depending on the severity of the case. We have very robust cheat detection software. As it turns out, we are CS majors, so we know how to detect plagiarism programmatically. The fact that you're in a 1,000-person class does not mean that we are going to be not catching every single pair of cheating. LLMs in general have a tendency to cause this kind of misconduct. I think 2 semesters ago, we had a huge ring of students, and the Center for Student Conduct kind of got mad at us for sending that many students. So please do not use that. It's not nice for either of us. And we will be checking your entire history. So we are not going to be fooled by things like variable renaming, switching around a few lines of code, copying code, testing it to see if it works, and then making changes. That's not going to work. And even if you bypass all of these cheat detection methods, you're really losing out a lot, right? You paid a lot of good money to come to this class and learn material. And if you cheat, you're basically losing out that ability to learn that material. Also, I've been told that my reputation is that I write hard exams. If you don't get the practice during the projects, you're probably not going to do well on the exams. So please do not cheat. Now, I do acknowledge that most of the time, I feel a lot of the cheating that happens is due to this kind of irrational cheating, right?
if you're desperate, you have like these major assignments, you'll end up doing things that you won't normally do, even if you know rationally that it's going to put yourself in a worse position later. Honestly, the best way to avoid this kind of irrational cheating is to make sure you never reach that point of desperation in the first place. So definitely plan ahead, start projects early. Part of the project is that aspect of getting stuck and then getting unstuck after. Plan enough buffer time to make sure that you are going to get stuck. Be warned that office hours is going to be way too packed as you get closer to the deadline. And we have, I think, about 80% the usual number of TA hours this time because of budget cuts. If you're falling behind in this class, that's okay. It happens. Let us know. We will work with you to maximize the amount of learning that you can get from this class. So that kind of brings us to our latest policy. So especially in weeks 1 through 5, we will be having a much stricter timing, but we will be having some extensions available. Just let us know, contact us through Beacon, and we will be allowing you to request extensions. We can allow for some retroactive extensions, but please request ahead of time, just so that you're planning ahead, just so that we have a way to ensure you get those before time. If you have extenuating circumstances beyond what we allow for standard extensions, let us know as well. We will try to be flexible. General rule is if we feel that you're falling behind in the class so much that you're starting to be in danger of not learning enough of the material, then we will push back. But until that point, we are going to try to be flexible and ensure that you get those extensions you want, so you don't have to resort to this kind of irrational cheating behavior. All right. Any questions on our cheating policy, lateness policies, or any of our other policies? All right. In that case, I think that's enough of a spiel about our logistics. Let's get started with our first Java programs.
All right, thank you, Jess. Let's do it. Okay, so I'm assuming everybody here has seen Python, but there's maybe a small handful of you who have never. That's okay, but I know that the vast majority of you have taken E7 or a CS61A or Data 88 or Data 8, and therefore we've seen some Python. So if you've already seen Java before, this might be a little boring, but I still think it'll be nice to do some reflection on the structure of the Java language. This link right here is not yet live, but I'll make it live. So if you tried clicking on this and it didn't do anything, that's fine. I'll fix it shortly. So what I'm going to do here is I'm going to pop into a text editor, and I'm going to write a couple of programs side by side. Over here, I'm going to write print hello world and Python. And then I'm using Sublime Text. You guys won't use that in this class, and I'll talk about an alternative in a bit. But in Sublime Text, if I have a keyboard shortcut set up so that if I press a special button, I get hello world. Okay, so I do hello world exclamation point. It's hello world exclamation point. Let's try doing that in Java over here. So in Java, if I were to just copy and paste hello world, the Java compiler will get confused and angry, and it will say, I don't know what any of this means. In fact, what it says is error class interface enum or record expected. And that's because unless you're using a very special new feature in Java, every Java program must start with one of these three things: a class declaration, an interface declaration, or an enum. Okay, what's that? Don't worry too much. So I'm going to make a class, though. But the way I'm going to do that is I'm going to write public class hello world. And now if I run this code, I get another error. Main method not found in class hello world. Please define the main method as this. Okay, so Java programs also need this. Okay, we're going to make this a little smaller. So Python in general is a less verbose language. As we can see, as we had to resize our window. And we'll have to even shrink our font slightly. And once we've done that, this program over here in Java, a language that perhaps many of you, you have not seen it. It's a great language. I actually really like Java, but it is very verbose. And this is the program in Java which does nothing, right? So over here on the left is Python, and this is Java. So Java is more verbose, clearly. Now, if we want to actually print hello world, what I'm going to do next is instead of just saying print, I'm going to say system.out.print. You feel like a hacker, like that's exciting. That's how I print things out. And when I do that, I need to now add a semicolon. And when I run this, I now get hello world. Okay. So we notice it is more verbose, but that verbosity will actually be a tool. because Java code needs to be organized in various ways that will keep you from being able to code dangerously. It has a lot of strict rules, and rules are good, right? We don't want too much freedom in life, at least when writing programs. You might notice this time is longer, and that's not because Java is slower. In fact, Java is much, much faster than Python for any purpose. It's just that Java has a startup time. But if I wrote a non-trivial program that sorted numbers or something, Java would be much faster. Okay. Any questions? Oops, I unplugged myself. All right. Questions or thoughts about this so far? No? Yeah. Yeah. Oh, yeah. And I'll tell you all about it soon. This is going to be a required IDE, in fact. I got to reshare my screen since I unplugged something. All right. Yeah. Okay. Other thoughts? No. Let's do some observations. My first observation in Java is that I have a cheat sheet for myself so I don't forget them. All code in Java has to be part of a class. Okay, that's different than Python. This code's just free floating. Over here, it's not. Another thing is we delimit the beginning and ends of things. I guess I'll call them code segments with left bracket and right bracket. That's another thing in Java. The third thing is that all statements in Java end in a semicolon. That's just one of the rules about how Java works. That's how it knows where one statement begins and the other ends. And the last thing we have is that for code to run, we put it inside of public static void main string args. Okay, that's just the thing you do. Okay, that's our first program. Let's do another one that's more interesting. Okay, so now we got hello numbers, we're gonna call it. Hello numbers does the following. We say x equals 0 while x is less than 10. X equals x plus 1, print x. So in Python, even if you don't know Python, you could probably guess this is going to print the numbers from 0 to 9. No, 10, in fact. I put it beforehand. I would put after. Doesn't really matter. Okay, so there you go. Got 0 through 9 there. Okay. In Java, we will see that things are a little more complicated, of course. Oh, let's see, I'm going to name my file first. Okay, so we'll do a public class hello numbers. And by the way, the file, since I named it hello numbers.java, the class has to be called hello numbers. I'll say main, that's a shortcut and Sublime Text. And now I'm going to write some code. So I say x equals 0, while x less than 10, you have to have parentheses in Java. And by the way, I'm not going to go through all those little language details. That'll be homework 0. We're now going to print out x, and then say x equals x plus 1. Okay. This is almost correct, but when I run it, Java yells at me and it says, cannot find symbol. Okay. So it's confused. It doesn't know what x means. And the reason is that Java, it requires you to actually declare that a variable exists before you can use it, like a formal declaration. The way that I prefer to do this in Java, I'm not going to tell you the other way, is to specify exactly which type. And the way I do that is I say, for example, int x. So this is a line of code that says x now exists and it is an integer, and it will always be an integer. And if I do that, now my code runs. Okay. So a little more verbose again than the Python equivalent, but again, it's going to be, as you'll see, especially when we get to project 3 long from now, a good thing. Now, one of the reasons that I like Java is that it's very picky about types. So for example, if later I decide that x is horse, which I can do in Python just fine, right? Like in Python, I can redefine print x. I can print out horse just fine. But over here, if I try running this code, I get an error, and that error is incompatible types. You can't take a string and put it in an integer home. That's not allowed. Now, this is such a tremendously important thing. It's my favorite thing about Java. And once you get good at Java and then you go back to writing Python someday, this is what you'll miss, is this fact that you know what things are, especially when it comes to writing functions. There's actually another interesting property here, which is subtle, which is that this error, it happens before the program even starts. So the Java compiler actually looks at the code and says, there's a problem. Like, this is garbage. I'm not even going to run this. It's just so bad it can't be run. In Python, I can do terrible things later. Like I could say x equals x plus horse or something. And Python will hate that. It's going to crash at runtime. It's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm killing it. Uh-oh, I crashed. You can't add an integer and a string in Python. Java doesn't have that class of error exactly. Like there's a whole category of things that cannot go wrong in Java that your compiler will yell at you and it won't even run your code. It's huge, big deal. This statically typed language property, that's what this is called, static typing. It is a profoundly useful tool for avoiding problems, but it also makes your language more verbose and a little less flexible because you can do all kinds of crazy things in Python. Java doesn't let you do those crazy things. And in my opinion, when you're building software systems rather than prototypes, it's wonderful. It makes software development way less annoying. Questions or things you want me to do? So even if you knew Java, hopefully it's still enlightening to see that difference. Thoughts, anything? Okay. Let me tell you what I think is important here. One, before Java variables can be used, they must be declared. Two. Two is that Java variables have a specific type. That type can never change, and types are verified before the code runs. This is also known as static type checking. Maybe we'll call it that. And maybe I'll make a note here, that type can never change. This is why these types are called static types, because they're static. All right. I heard a sigh. All right, we'll make it more fun. Oh, I see a hand being raised. Yes, online friend. What you got for me? Actually, do you want to answer in the chat? Okay, great. All right, thank you. All right, he's got the chat. Good. Okay. All right, let's do a more interesting program. One more. Yeah?
Also, tell the people on Zoom, a lot of them are responding to other students using hosts and panelists only.
Oh, yeah. If you're responding to hosts and panelists, they were talking to other, oh yeah, students, online students. Make sure you respond to everyone, not hosts and panelists, because other folks are not seeing the things you're saying. Okay, got it, Zoom? All right, good. Okay. And one more program. We're going to write some functions. Functions are obviously really handy. So I'm going to make a function called larger, and it's going to say if x is greater than y, return x. Otherwise, return y. Great. Oops. Thank you, Sublime Text. All right. And then I could do, for example, what's the larger of 3 and 5? Or what's the larger of cat and zebra? Okay. What do you think is the larger of cat and zebra? Zebra, why? Alphabetical order, maybe? Yeah, that's the reason. Okay. So if I run these, I get 5 and zebra. Good. Okay, in Java, let's do that one. Larger demo. Larger demo. Okay, main. And then we're going to define some, we want to do system.out.print line larger of 3 and 5, but we do not have yet a larger function. So how do we declare a function in Java? It's not def, but it is for now. It's public static. That's just what we're going to do. So that says there'll be a function named larger that takes an x and a y. If x is less or x is greater than y, a little bit of echo here. I'll talk a little quiet. Otherwise, we'll return y. Okay. This is pretty close, but can you guess what Java is going to complain about these? They need types. Yeah, okay. So we're going to make them integers. We try running it. We're close, but now we get return type required. Okay. So what we have now is Java wants us to say what larger returns. Where does it go? It goes before the name of the function. So you can think of this for now as meaning def. Are there functions that don't have static? Sure. Are there things that have something other than public? Yes. But for us, public static is def. And then here we have int. If we run this code now, it works. Okay. Now, what's nice about this idea of a function declaration is that you know exactly what you're getting. 2 integers. So the domain of this function is a pair of integers, and the range is an integer. And that's very unlike a Python function where the domain and range could be anything. Okay? It does mean, of course, that if I want to do what is the larger of horse and zebra, I mean, this isn't going to work. It'll say, I have no idea what this means. You can't put integers into a string box or strings in an integer box. So what could we do here? Like, what do you think? What's some solution? I mean, you could maybe make another function also called larger that takes strings. And indeed, that's one way to do this. And we'll get into in about 3 weeks, like the real way to do this, but this is pretty close. And actually in Java, a lot of times you actually have multiple functions with the same name and different what are so-called signatures, but I'm not going to do that now. So Java functions, less flexible, but they're more precisely defined. The trade-off. But in this case, I'd say that for the kinds of code, when you're building massive pieces of software, static type checking, a lot of people like it. Some people don't. Questions or other things you might want me to do. Yeah. Well, is the correct way using generics? Not quite. The correct way is, I'll just tell you, is to do public static. Well, I'm going to use something called a comparable. And then it's going to be, well, I want to get into it. I think it looks, this is what I think this is the signature. Larger T, X, T, Y. Something like that. So generics, but the generics have to be comparable. This isn't quite right, but something like that. 2 weeks from now. Other thoughts? Yeah. My typing speed. I'm a little slower than I used to be, but I'm about a 120 words per minute. But I think I'm probably not that fast anymore. I'm declining into middle age, so.
I'm at like 60.
60. Yeah, I know, but like this is my superpower. There's one person I know who's much faster typing than me, and that's Jelani Nelson. It's incredible. I'm so impressed when I watch him type. When 61A had its typing game, though, the first time I was on the top of the leaderboard. That was fun. All right, next. Other thoughts. I was also pretty good at StarCraft 1 a long time ago, but I used up all my clicks. I also used to watch Korean StarCraft, by the way. That was my engagement with Korean culture in the 2000s. Anyway, moving on though. Any J-Dong fans here? Too young. Before your time. All right, go ahead. Other questions about functions in Java? No. All right, cool. Sounds good. All right, I will give you. I'm taking the room back, everybody. I had too much fun. Observations about this. Okay. Functions must be part of a class. So unlike Python, where functions can just float out in the ether, here this function is part of the class larger demo. It doesn't exist apart from larger demo. If another class wanted to use it, it would have to say, hey, larger demo, please give me your larger function. I'll have a little piece of terminology here, which is that a function that is part of a class is sometimes called a method. That's just a word that's used in the world, not just in our class. Therefore, all functions in Java are methods. To define a function in Java, we use, for today, public static. We'll see other ways. 3, all parameters of a function must have a declared type. And, oops, and the function must return a specific type. All right. These are all things you'll come to know very well. Okay. Also, functions in Java only return one value. Let's suppose you wanted to return more things. What do you do? You declare a new type, and then you can bundle a bunch of things together. We'll see that. Okay. Any other questions before I go back to slide world? Okay. Skipping along, because these are just the same observations that we just saw in the text files. So they're just here in the slides for your reference. Okay. So let's talk just a tiny bit about workflows and compilation versus interpretation. I think this is a useful fact to know about how the type checking works. So while it was invisible to you while I was working, when I create a .java file, what Java does to run a program is a two-stage process. First, there's a compiler, which looks at the Java source code and turns it into something called bytecode. We won't talk about the inner workings of bytecode, but it's not that hard to learn, but it's not important to us. And it creates this so-called .class file. That is then passed to the interpreter, And the reason it's done in two stages is that this interpreter can, in theory, take all kinds of different programming languages like Scala or whatever else out there. They could be compiled into bytecode. And then this interpreter is just like one of the world's most magnificently engineered virtual machines for running code. And as I'll talk about way later, in like 2.5 months, it does some wild optimizations to make code very, very fast. And these class files are basically like a lingua franca for this interpreter to be able to run code that potentially comes from many languages. And it's also just simpler than the Java programming language. So you can think of the .class file as a different kind of hard to write manually language that this interpreter runs very quickly. And the idea is that like it's just easier to write a very fast compiler for a simple language like bytecode. So when you run the Java interpreter, stuff happens, and these two steps are separate. So I've already talked a little bit about why to make a class file at all. But a couple of reasons I didn't mention is class files also have the added benefit that they're type checked. So the compiler's already checked to see you're never putting integers in a string box. We're not going to run into those problems we had with Python. And as I alluded to just a minute ago, class files are simpler for reasons beyond the scope of our class for our machine to execute. So the code we give out is going to be faster. We give the .class files out. Then there's also a tiny, tiny benefit, which is maybe to some degree it protects your intellectual property because you don't need to give out your .java files. You can just give out the .class files. Though I'll note that it's actually pretty trivial to reverse engineer, or not reverse engineer, just reverse it into a pretty similar looking Java file. But they don't get your exact code. If you're curious about this sort of thing, by the way, 61C will cover these ideas. But especially 164, we'll cover them in more detail. All right. So thinking about static typing, okay. I don't know. I'm going to have you guys talk for a minute. How about that? Okay. You saw some answers, but what are some things that maybe seem good about this whole, like, we have types, they get checked? I don't know. Give me some sense of what might feel good about static typing. Give me some answers, but I want to hear what you think. Yeah. Yeah, always know what things are, right? Always know what things are. Maybe more generally, easier to reason about code. And that's a huge benefit. Yeah. Right, less opportunity for user input to cause a problem. Right, because you're just checking things as you go. And I can even expand on it a little bit and say many fewer bugs possible. By the way, there's languages that try to avoid null pointer exceptions, which Java allows. That's also another thing that people try to do with engineer languages where you can't have null pointer problems. I've thought about moving this class to such a language, but I've never had the guts to do it. All right, other good things maybe. Yeah. Say again? Early error detection, right, exactly. That goes with the fewer bugs possible. Right when you write in the code. You can fix it right when you write it. And your IDE will complain. I'll take some negatives. What's something that's maybe negative about static typing? Yeah?
You can't switch like the execute scores. You never do that.
Right. Less flexibility. Can't decide X is a horse. Okay, fair. Other thoughts? Yeah? Makes the language much more verbose. Okay, yeah. Kind of said a lot of those things already. Sorry, it's a little silly. Tricky syntax. Yeah, that's a big one. The syntax gets very weird for methods that need to deal with very specific types with certain properties. And we'll see that later. All right. One more thing I want to talk about then is workflow, and then I'll release you to the world. So I said that implicitly, Java is always doing a two-step process. Where is this file even stored? Oh, yeah. Java is always doing a two-step process of compiling. You have it in you. I believe in you, everyone. To be chill for 1 minute.
2 minutes of class.
2 minutes. Come on, guys.
Please do not leave until class is dismissed.
All right. Justin's the cop of the class. Thank you. All right. So I'm going to show you real quick what happens when I do so hello world.java, you seen it? If I use Java C, it produces a new file called hello world.class. And you can open that like any other file. Here it is. This is the mystery of bytecode. You can see that you can kind of read it, right? We've got a Java lang object, all this stuff. So that's one way that you can run Java code. And that's the way we used to do 61B back in Spring 14 or Spring 15. Most we have people doing this command line stuff. Again, you feel like a hacker. In that case, you run your programs like so. There's another way to do all this, which is to do fancy text editor tricks like I did. You guys have also seen Jupyter notebooks in Data 8, where you're running and writing code in the same. Come on, guys. All right. Just simmer down. All right. Anyway, I went on a tirade. They couldn't deal with the things I was saying. They're command line enthusiasts. Anyway. So the last thing is that in this class, we're going to suggest that we use an integrated development environment where you're going to write your code and run it in the same environment. And it has all these very nice features like autocomplete, that it's continuously checking whether or not your syntax is correct. And it also does neat things like decompile from .class files to .java files. So if you will allow me, before you get on to the next thing, I will show you briefly what one of these pieces, what this IDE looks like. So in this IDE, we're going to make you use this big, complicated industrial strength software used in the real world, which is very nice because if you do things that don't work, so this is the actual testing code for the project you'll be doing soon. If I do something I'm not allowed to do, like, int x equals horse, it's going to get mad at me. And you get a squiggly underline, and it'll be yelling at you as you go. So I would like you to enjoy using IntelliJ as the semester goes. Please remember, there's a homework 0 that you should get started on. And that's all. See everybody. All right. Yeah. All right. We'll stick around at the beginning. Okay. Yeah, go ahead. Yeah. How do you go about claiming the fixing points? There will be a form you fill out where we track attendance that way. Yeah. Yep. So we have a survey that said, like, did you go to discussion? The honor system, basically. Yeah. 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 Say your name. Surya. Okay. Surya. That's who are like. Yeah. Yeah. Java already? Well, someone just has to write the compiler. Someone could write a Python compiler. I don't think anybody really wants to do this. Python does not. But there are other languages that it's kind of funny to think, right? There's a Python. Python uses, well, it's actually many different Python. But it uses different functions. I think often they do a have you ever noticed the .py file generated by Python? And that's when Python takes the interpreter takes the code and it the file set. Sometimes virtually my file. Yeah. I don't know exactly the details. One of the main Python is it doesn't have the notion of like declared rights.
I've done very little Java, but recently I've done a lot of C#. I know syntax is very similar. Things end up being very similar.
You already know most of what we're going to do for the next. You start a slightly nicer version of Java. Yeah. Yeah, what goes into two things? Like, why did you choose well, I didn't actually. The class has been using Java since around 1997. The reason that I still the programming language is extremely popular, like in the top 5 languages. And it, like the other one I could pick probably would make sense would be C++ or C++. But C++ requires you to manage your own memory, which is it's like an extra layer. It makes it really harder to do, and it's not worth it. So I see that what let's have it, you get major advantages in terms of that checking and speed. Going on to just a more sophisticated language like C++. But it could do something like Kotlin.
Oh, I thought this was kind of stupid, and then 200 people showed up. So then
You can unplug me. Yeah.
oh, okay. Yeah, that's fine. That's pretty funny.
Yeah. Oh, earlier. Oh, right. Just one round.
Okay,
Starts here, and if not,
Yeah.
try opening random doors.
What'd you lose? A water bottle. Thank you. Oh, yeah. I left it in here this morning, I think.
Memory model, we would have to pull up and say, all the same.
Think it's surplus? 500. Oh, you'll be okay. Well, we're probably at a 550, but well, yeah. I mean, we're slightly over room capacity. Yeah, I mean, 60 was 1200, so it wasn't even close. Yeah. Yeah. Testing. Testing. All right.
And I gotta get going.
Folks are 16B. I'm gonna close this or push out of the way.
So in the setup, there should be a part where you do import library.
So actually, sorry.
Oh yeah, go ahead. Where are we at? What time is it?
You got 5 minutes.
Okay. Libraries. Yeah, so you'll need to make sure. Wait, I thought it was 161.
No, I'm free.
Oh, you're free.
Yeah.
Setting up. Yeah, this right here. This is the part that it's yelling about. I gotta run to my next thing. I think. Yeah. Yeah. Do you want me to? Oh, yeah, yeah. There's office hours. Yeah. He's trying to set up the libraries import for